Our universe began with a bang, or so many scientists believe. We can't yet say for sure how it truly began, but we do know a thing or two about how it works. Atoms collided, giving us clusters of atoms, clusters of matter, gravity, stars, galaxies, clusters of galaxies, and many other structures, both incredibly large and unimaginably small. Each of these structures in our universe come into existence. They exist, and at some point, they cease to exist. Stars are no exception. At the very beginning of a star's life, dust resides in vast clouds of matter called nebulae. These clouds are spinning very slowly, and when something disrupts the cloud, like the explosion of a nearby star, the cloud starts to collapse. Matter starts to become concentrated in particular regions, and as more and more matter is attracted to those regions due to the increasing gravitational pull, the regions begin to spin faster and faster. While the clump of matter is collapsing, it heats up. The hydrogen atoms at the core of the fledgling star, known as a protostar, are both immensely hot and under extreme pressure, causing them to begin fusing together to make helium atoms. 4 hydrogen atoms fuse together to create a single helium atom in this nuclear furnace known as a star. This fusion process has a name, stellar nucleosynthesis, which refers to the facts that it is a star, that it happens at the nuclear center of atoms, and that hydrogen is being combined with heat and pressure. Depending on the size of the star, it can continue to convert hydrogen for millions or billions of years. Some stars are simply too large or too small to maintain stellar nucleosynthesis for very long. This part of a star's life, where it is burning and fusing, emitting light, and energy is pushing outward only as much as gravity is pulling inward, is the star's main sequence. Our own star, the Sun, is only about 5 billion years old, and still in its main sequence. The main sequence is the longest part of most stars' lives, and is extremely stable when compared with some of the ways stars can die. Some stars simply begin to fade with time. They become cooler and darker, able to generate heat, but not able to generate light. They simply fade out and die. Other stars use up the hydrogen fuel in their cores fairly quickly, leaving little outward push from radiation, instead giving gravity the upper hand. Gravity pulls the matter that makes up the star quickly toward the center, rebounds, and sends the matter flying in every direction away from the star, into empty space. Supernova explosions, as they are known, litter the universe with the remains of a star. The elements generated during the star's life are repurposed to make rocks, planets, and all the matter we know, including us. This is what Carl Sagan meant when he said, "We are all made of star stuff." Some large stars collapse to form a neutron star, an extremely dense star relatively small in size. Some very large stars collapse and form a black hole, an object with gravity so immense that light itself cannot escape once subsumed.